My dear students, colleagues and friends, in this video I'm going to show how to compute Spearman's rank order correlation coefficient. In one of our previous videos I discussed the Pearson correlation coefficient between two quantitative variables. So the question is, what is the difference between Carl Pearson's and Spearman's rank correlation coefficient, and how we can compute that? So I'll be using some hypothetical data, and I'll do that in SPSS. So let me start with the definition. Before I compute the Spearman's rank correlation, let me introduce and define the rank correlation coefficient. So the Spearman's rank correlation coefficient is shown by Greek letter pronounced as rho, and it is a non-parametric test to measure the strength and direction of association that exists between two variables measured on at least an ordinal scale. As I mentioned, it is denoted by RS, that is a correlation coefficient. Spearman's correlation coefficient are the Greek letter pronounced rho. I mentioned that earlier. This test is used for either ordinal measurement scale or for continuous data, that is quantitative data, which has failed the assumptions that are necessary for conducting the Pearson's product moment correlation. So if the assumptions necessary for conducting Pearson's product moment correlation are not fulfilled, then in that case we may use Spearman's rank order correlation coefficient to continuous data set. As I mentioned earlier, Spearman's correlation is a statistical measure of rank correlation, that is monotonic relationship that determines the strength and direction, whether linear or non-linear, of the monotonic relationship between two variables x and y, rather than the strength and direction of the linear relationship between two variables, which is what Pearson's correlation coefficient determines. Possible alternatives to Spearman's correlation are Kendall's tau, B-test, or Goodman and Crooksal's gamma test. And as usual, the rank of the Spearman's rank correlation coefficient is from -1 to +1. That is the value of rho. That is the value of the Spearman's rank correlation coefficient ranges between -1 and +1. And its interpretation is similar to the Pearson's. That is, the closer rho is to the ±1, the stronger the monotonic relationship. If it is close to +1, then it shows a positive correlation and stronger positive monotonic relationship. But if it is close to -1, then there is a stronger negative monotonic relationship between the two variables. Let me share with you a small example to explain how Spearman's rank correlation coefficient can be computed manually. Let us suppose there are 9 students who took exams in physics and maths, and their scores are as follows. These are the scores of 9 students in physics and maths respectively. Now we may compute the students' ranks in the two subjects and compute the Spearman rank correlation as follows. A Spearman's rank correlation between x and y is calculated by this formula. Rho is equal to 1 minus 6 into summation I varies from 1 to n di square divided by n into n square minus 1. So we have to rank the two variables, and then we have to find the difference between the two ranks, and putting these values in this formula we can get the value of the Spearman's rank correlation. So here in this formula, D is the difference between ranks, and in this slide you can see that these are the 9 scores. These are the scores of 9 students in physics, and we show that by x and this is the score of 9 students in mathematics, and we denote this variable by y. So this is rank of x. So rank of x can be calculated like that. So this is the highest score, so we give this rank 1. This is the second highest score, so rank is 2. Similarly, this is third, and so on. So how we rank them in this way. Similarly, for maths, we also can rank starting with 1 as the highest score, and then 2 the second highest score, 3 this is the third highest score, and so on. And here is the deviation between the rank of x minus rank of y. So 3 minus 5 is equal to minus 2. Similarly, 5 minus 3 is equal to 2, and so on. And then we get the since in the formula there is di square, so we will take the square of these values and we get d square. So minus 2 multiplied by minus 2 is equal to 4. 2 times 2 is equal to 4. Minus 1 times minus 1 is equal to 1. Minus 1 times minus 1 is equal to 1. Similarly, 1 times 1 is equal to 1, and so on. So if we sum up these values, we get summation d is equal to the summation d square is equal to 12. If we put these information in this formula, then rho hat, that is the estimated value, the estimated value or the predicted value of Spearman's rank correlation is 1 minus 6. Then summation di square is 12. N is equal to 9, and n square is equal to 81 and 1. So if we put these values here in this formula and simplify, then Spearman's rank correlation is equal to 0.9, which is very strong. Okay, so as I mentioned earlier, let me use this data in SPSS, and the example that you saw in the slides of the PowerPoint presentation. So here I have score of 9 students in physics, and here I have scores of 9 students in mathematics. So let me see how can we compute a rank correlation, Spearman's rank order correlation coefficient for these two variables. So after navigating to analyze, then I'll come down to correlate, and then I'll click on bivariate, and I will use these two variables which I have already here. So originally this space will be empty. So whatever variable we will use for computing Spearman's rank correlation, we will have to use those variables here in this space. And originally this correlation will be the Pearson correlation coefficient will be ticked, but since we want to compute Spearman's rank correlation, because we assume that the assumptions that are necessary for computing Pearson's correlation coefficient are not fulfilled, and these data may be ranked on ordinal scale. So let us compute Spearman's rank correlation for this. So if I click OK, here is a non-parametric test. So Spearman's rank correlation coefficient is a non-parametric correlation, and it says Spearman's rho. So rho is the coefficient of correlation defined by Spearman's rank order correlation, and this one shows the Spearman's rank correlation between physics and physics, which is a positive one. So this is the extreme case, perfect positive correlation of physics, of marks in physics and marks in physics. And this is the Spearman's rank correlation between marks in mathematics and marks in physics of the 9 students. So this is exactly the same that we just found out manually in the PowerPoint show. So this 0.90 and its associated p value is 0.001. So this is a very strong and high correlation between Spearman's rank correlation coefficient between maths and physics. The same is here also. So here this is a Spearman's rank correlation coefficient between mathematics and physics, and both of them are the same. So this is highly significant. Let me also give you another example with which is already ranked data. Okay, so here are 5 students A, B, C, D, E, and that is the ranking of these 5 students in English subject. So A got rank 1, B got rank 2, C got rank 3, and D 4, and the rank of E was 5. But so far as marks in maths are concerned, B got first rank, A got second rank, C got third rank, and D got fourth rank, and E got fifth rank. So now let me compute Spearman's rank correlation coefficient for these two variables. So again, previously I computed Spearman's rank correlation between physics and mathematics, and that was the score of 9 students. So this time I'm using another data set in which there are only 5 students, and marks are in English and math. So let me send both of these variables here and make it sure that the Spearman rank correlation coefficient is checked here. So it is already checked, so let me okay. And this also shows the non-parametric correlation coefficient, that is Spearman's, and there are 2 subjects, English and math. So the Spearman's rank correlation coefficient between English and English is 1, that is a perfectly positive correlation. But the Spearman's rank correlation coefficient rho between English and math is 0.900, and its p-value is 0.37. Earlier this p-value was 0.001, and that was the Spearman's rank correlation between physics and mathematics. This is between English and mathematics. Again here, this is also Spearman's rank correlation coefficient between math and English, and its p-value is less than 0.05. So we reject the null hypothesis of no correlation, and we conclude that there is a strong positive correlation between the score of 5 students, between the ranked score of 5 students in English and math. So my dear students, this is how we compute Spearman's rank correlation. And the question that I asked earlier was, what is the main difference between Pearson correlation coefficient and Spearman's rank correlation coefficient? The only difference between the two is that we usually compute Pearson correlation coefficient for the data that fulfill the requirements or the assumptions which are required for computing Spearman's Pearson's correlation coefficient. But if the data is on ordinal scale, or if the data set is ranked on ordinal scale, then in that case, or if the data is continuous but they don't fulfill the assumptions required for Pearson's correlation coefficient, then in that case we compute Spearman's rank data correlation coefficient denoted by rho, that is the Greek letter. I hope this is quite useful and informative. If you like this video, kindly share this video with your students, with your colleagues, with your friends, and share this video with the various WhatsApp groups members, so that it could reach to the maximum possible number of people. And don't forget to subscribe to the channel and click on the bell icon, so that you can get notifications about my other videos that I'll upload for you. Thanks for